Okay. So yesterday, the day before, we were doing, I think, some questions on continuity, right? So today we are going to continue from there only. Let us take some easy question at first, and then we'll go for difficult ones. So we were discussing continuity of real value functions. Okay. Now, today we are going to focus our attention more on the exam questions. Okay, so we have done two properties till now, and we'll see difficult questions also. But today, let us see some questions first. So we'll try to do some. Okay. The first one is let fx equals to tan of pi by 4 plus x for all x not equal to 0 and raised to power 1 upon x. And at x equal to 0, it is given to be equal to k. Find the value of k for which fx is continuous. Find the value of k for which fx is continuous. So how to go about it? How to do this particular thing? See, I know that my function is given to be continuous. It implies limit x tends to 0, 1 plus tan x divided by 1 minus tan x, because 10 pi by 4 plus x is what? 1 plus tan x upon 1 minus tan x. Is it clear? Raised to power 1 upon x. It should be equal to what? It should be equal to the value of the function at that point. So on the very first day when we were discussing continuity, what does it mean? That I will say that my function is continuous. Function is continuous at x equal to a if limit x tends to a f of x is equal to f of a, right? Harshit, is that clear?
Yes, sir.
Okay, so the limit on the left hand side, like limit this particular side should be equals to k, because f of 0 is simply k, right? So what I'll do, I'll try to find the limit x tends to 0, and I will simply write 1 plus tan x, and I'll take a power of 1 upon tan x. While I'll do so, see, here it is a tan x, and as x tends to 0, this is going to 0, and 1 upon tan x goes to infinity. So if you remember one of the formula that I wrote, that limit x tends to 0, 1 plus lambda x raised to power 1 upon x is simply e raised to power 1. Right? So it is e raised to power lambda, then what it implies, so I'll do 1 upon tan x here. And what is to be done? In excess, I have this tan x divided by x. And then I will also do the same for this. So 1 minus tan x, and I will also write 1 upon tan x and this whole raised to power. Is that clear? So what I've done, I have taken 1 upon tan x and then tan x upon x. As x tends to 0, I know that my tan x upon x tends to 1. So this will go to 1. And where this particular thing would go, because as x tends to 0, your tan x is going to 0. So here it is equivalent to writing this particular limit e ki power lambda. So upper one would be e ki power 1, lower one would be e ki power minus 1. Answer would be e square. So the value of k should be what? E square. Is that clear?
Yes, sir.
This is an easy question. Let us try to do more questions. From limits also, let us first take some questions from your exam, so that मतलब तुम्हारा थोड़ा confidence तुम्हें समझ में आए कि exam में क्या था. Okay, so we'll see a few questions from exam also. So try to do this. So question is simple, and it says that, I think this, I'll write the exam date also, like year also. Question is limit x tends to minus infinity, x raised to power 4 sine 1 upon x plus x square divided by 1 plus mod x the whole cube. Okay, this is the question. And this is not fractional part of x. Okay, so this is normally a bracket. Now you have to solve it. I'll do it for you. Just take a few minutes and then I'll solve it. Okay, so whenever you have this, what I'll do, I'll simply take, see here it is x cube now. So you always, whenever you have this power infinity now, you always take the highest power common. So that will help you out someday. So if you take x cube from here, so if I take x cube common from here, okay, so if you take x cube, or let us first resolve this. What is modulus of x? Modulus of x is equal x if x is greater than equal to 0, and it is equals to minus of x is x is less than 0. Is that clear? So this is one thing that you know. So as x tends to minus infinity, that implies your x is less than 0. So instead of modulus, I'll simply write minus of x. I'll write x tends to minus infinity. This is x raised to power 4. Right? I'll take an x cube common from here. So I'll take an x cube common from here. This will be simply x cube. If I take common from here, this will be simply x sine 1 upon x plus 1 upon x. So if you take x cube from here common, so here you will get 1 upon x cube. Is that clear? Okay, so I've taken x cube common. So if I divide x cube, the numerator entirely by x cube, this is what you're going to get. Is that clear? And now if you take x tends to minus infinity, what I can write, see this particular thing, I can write sine of 1 upon x divided by 1 upon x plus 1 upon x divided by 1 upon x cube minus. Now as x tends towards minus infinity, this will go towards 0, this would go towards 0, this would be 1, this would be 0 divided by 0 minus 1, this would be minus. Is that clear?
Yes, sir.
Okay. Another question. Let us take another question. Let's see if you're able to do it. You have to find me the points of discontinuity. You can find me the points of where this denotes greatest integer function. So you have to find the points of discontinuity of fx, which is equals to greatest integer of x, into sine pi divided by greatest integer of x plus 1. So we have to find the points of discontinuity. Okay, so the first step, whenever you have a question which has some sort of function involved in, the first thing that you should, and this is also from JEE exam. Okay, so first thing that you should find is what would be the domain of the function. So what do you think the domain of function would be? So clearly one can understand that your greatest integer x plus 1 should not be equal to 0, right? Because if it is equal to 0, then there could be difficulties, right? Or in other words, I will write that my x plus 1 should not lie between 1 and like 0 to 1. Is that clear?
Yes, sir.
Okay, and that would say that would imply, just kidding. Okay, and that would imply that x should not lie between -1 and 0. Or in other words, I can write that my domain would be all real R except this. Is that clear? So your function would be defined for all these values, right? And what do you know about greatest integer function? You know that from the graph that I drew on the very first day, that we have greatest integer x is discontinuous on is discontinuous on set of integers, right? Right?
Yes, sir.
So I'll write what would be the possible points of discontinuity. So I'll write what are the possible points of discontinuity. First, let us write the possible points of discontinuity. So possible points of discontinuity are what? It is equals to, let's say, -5, -4, -3, dash, 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 -2, -1, 0, 1, 2, 3, so on. Okay. According to this, so here your sign pi upon the greatest integer of x plus 1 is not defined. So you can understand that your what you can say that your in any case this particular thing should not be 0, because if this particular thing is 0, then things would not be right, isn't it?
Yes. Yes.
Okay. Okay. So for the definition of this particular function, the domain of function f should be all those x belongs to R, such that it should not lie between -1 and 0. This is one thing that is very much clear. Now, and these are the possible points of discontinuity for greatest integer of x. So greatest integer of x will not be defined if it lies between here to here, right?
Yes, sir.
Okay. Now, one has to also see that this is not only it, this is this also. So you have a greatest integer x multiplied by something. So if x lies between 0 and 1 also. So if x lies between 0 and 1, what will happen? X lies between 0 and 1. So this is what happened, right? So because greatest integer x plus 1, if it is equal to 0, then things will go wrong. If it is equal to 0 means what? X plus 1 should lie between -1 to 0. Now, if x lies between 0 and 1, so 0 and 1 also, you can see that eventually this particular function would be 0. Why it would be 0? Because this particular thing would become 0, whatever be the case, right?
Yes, sir.
Okay. Function will not be defined for all these values, because I'll write here fx will not be defined for all x belongs to -1, 0, right? Here your function will not be defined. Okay. Now, these are the possible set of discontinuities. Why these are discontinuities? Because here your greatest integer x would be discontinuous function, right? Because on all these integers, -5, -4, -3, -2, -1, 0, 1, 2, 3, these are the points of discontinuity of greatest integer function. Now you see your function, because you don't want that your x plus 1 greatest integer be equal to 0, that also evaded these values, right? So x cannot be between this, right? Now let us check if continuities at such points. So I'll check continuity at x equal to 0. So one of the integers you see here is x equal to 0 also, right? देखो मेरी बात सुनने की
Yes.
कोशिश करो. What I'm doing this question in two folds. The first thing is I want to see from here what would be the domain of the function. So from here I can clearly see that only domain that I can think of is from -infinity, -1 union 0, infinity. One thing is clear. But also understand the question was of the point of discontinuity. So I understand that my greatest integer x is discontinuous at all these points, right? So this I have written. Now I'm just thinking of a few things. Let's say the first thing that I think is that fx will not be defined at -1, 0. So let us check whether my function has some sort of continuity at x equal to 0. So because here you see that 0 is contained in the domain of the definition, right? And 0 is here also on the point of like discontinuity, right? Possible points of discontinuity. I'll write this here. So one thing is clear that at function is not defined at -1, 0, but you can see that like if I write r minus 1 comma 0, that implies your domain of f would be minus infinity comma minus 1 union 0 comma infinity. So from here you have all sort of integers. So all negative integers here, and here you will get all positive integers, isn't it? From here to like minus 1 will not be there, I guess. But I'll have to see for minus 1 also, right? So I'll see for two peculiar choices. One is, see here all the integers would come negative. Here all the positive integers would come, right? Now there is a problem at minus 1 and 0 because here the bracket is not like, are you getting my point? So
Yes, yes, sir. I got
check the let us check the continuity at x equal to 0 first. So I'll check the continuity at x equal to 0. So at x equal to 0, I'll first take the limit to the right, which is simply greatest integer x h sine of pi upon 1 plus h for greatest integer, isn't it? Right? Isn't it? To the left of x, equal to 0, fx is not defined. So we are not going to check the continuity at the left hand, isn't it? So always remember, whenever you have to check the continuity at the bounds, let's say here. So here you can only check the right hand continuity and the value of the function at that point. You cannot go for the left hand continuity because to the left of a is your domain of definition is not there. Is that clear?
Yes.
Okay. So I'll write that to the left, your limit left hand will not exist, right? Because see, your function is not defined to the left of 0. So to the left of 0, your function is not defined, right? The function is not defined from minus 1 comma 0, isn't it? And what will be f of 0? F of 0 simply would be 0 into sine pi against 0. So it is clear that your right hand limit exists and it is equal to f of 0, but left hand limit cannot be evaluated since it is not in the domain of the definition of the function, right? समझ पा रहे हो मेरी बात? देखो डोमेन में है ही नहीं ना. अगर अब तुम डोमेन कहोगे f की तो क्या होगी? The domain of f would be simply minus infinity comma minus 1 union 0 comma infinity. तो 0 पे कैसे चेक करो कंटिन्यूटी? एक तो 0 पे चेक कर लो और टू द राइट चेक कर लो, क्योंकि टू द लेफ्ट तो आएगा ही नहीं ना. लेफ्ट तो उसमें कंटेंट ही नहीं है डोमेन के अंदर. सो क्लियरली 0 पे फंक्शन इज कंटिन्यूअस. Why function is continuous? Since f0 is defined and right hand limit is defined. Left hand limit क्यों नहीं ले सकते? Because left hand limit will not exist since your function is not defined. Since f is not defined. Is that clear or not clear?
नहीं सर, समझ में आ गया.
समझ में आ गया ना? इसका मतलब इसकी सेट ऑफ कंटिन्यूटीज में से किसको हटा सकते हैं? सेट ऑफ डिसकंटिन्यूटीज में किसको हटा सकते हैं? तो z तो आ ही जाएगा एक्सेप्ट 0, बिकॉज 0 पे क्या हो गया? कंटिन्यूअस. इज दैट क्लियर और नॉट क्लियर? और माइनस 1 पे भी देखो, ये डिफाइंड ही नहीं है, मतलब तो माइनस 1 भी डिसकंटिन्यूटी नहीं आ जाएगा. जहां पर भी फंक्शन डिफाइंड नहीं होता वहां पे फंक्शन डिसकंटिन्यूअस होता है, याद रखो. ठीक है? सो फॉर अ फंक्शन टू बी कंटिन्यूअस, फंक्शन मस्ट बी डिफाइंड एट दैट पर्टिकुलर पॉइंट, राइट? थोड़ा सा डिफरेंशियबिलिटी आता है, नहीं आता, हल्का सा. इफ आई से आई विल से दैट माय फंक्शन, एक छोटा सी हिंट दे देता हूं. आई विल डू इट अगेन आल्सो. इफ f is differentiable at point x equal to x naught, then limit h tends to 0 f of x naught plus h minus f of x naught divided by h. This represents your right hand derivative, must be equals to limit h tends to 0 f of x naught minus h minus of f of x naught divided by minus. You remember this? This is called as left-hand derivative. This is called as right-hand derivative. This is I'm just giving you, for example, if some question के अंदर कहीं अटक गई तो हालांकि I'll not give you any question of differentiability right now, but if कहीं कोई question आता है तो at least you should remember the differential part. So we were doing one question from JEE only, so let us try to do a few more questions from JEE exam, so that तुम्हें ये लगे कि तुम exam लायक कितने तैयार हो. अभी तक तो कोई दिक्कत नहीं आ रही ना questions में?
नहीं सर, अभी तक नहीं है.
ओके, चलो एक क्वेश्चन करते हैं, कंटिन्यूटी के करते हैं पहले, ठीक. सो लेट अस फर्स्ट डू द क्वेश्चंस ऑफ दिस कंटिन्यूटी. ठीक है, अगेन JEE 93. fx is given by greatest integer x cos of 2x minus 1 divided by 2. This function is discontinuous at all x, option number 1, b, all integral points, c, no x, and d, x which is not integer. How to think about this? So let us first define the function. Okay, let us first define the function. So I'll define this particular function f of x. Okay, so एक काम करते थोड़ा सा कुछ expand करने की कोशिश करते हैं. So let us first write from एक काम करते 0 से लेकर 1. एक काम करते थोड़ा 0 से लेकर 1 ऐसे बीच में लिखते हैं. Let us try to write from 0 to 1. So from 0 to 1, you know that your greatest integer x would be 0 simply, right? From x lying between 1 and 2, your greatest integer x would be simply 1, and this would be cos of 2x minus 1 divided by 2. And there's a pi also here, sorry, there's a pi also. Similarly, if you write from minus 1 to 0, your this would be minus of cos of 2x minus 1 upon. Whenever your x lies between 2 and 3, your greatest integer x would become simply 2, and this would be cos of. And if I go all along and write from minus 2 to minus 1, this will be minus 2 cos of 2x minus 1 divided by 2. Is that clear?
Yes sir.
Now you see, this is how it is, and you can go along from here. Okay. Now one can see that if I want to, I know that my what you can say, my function is discontinuous. Mostly, if I say for greatest integer of x, my function is discontinuous. My function is discontinuous at usually what we say that my function is discontinuous at integers, right? Here also you see at integers you can see that there is a change of definition. ठीक है, देखो x जब 1 से छोटा था तो 0 था, x जब 1 से बड़ा हो गया तो cos 2x minus 1 upon 2x minus 1 upon 2 pi हो गया. So you can clearly see that at x equals to integers, at x belongs to integers, function is, I'll not say discontinuous, but function changes definition. We'll see about continuity, but first understand function changes the definition, right? In between, you know that cos function is 0, cos function is cos x is a continuous function. You know this thing. Sin x and cosine x are continuous function. So your cosine x, या फिर your function f of x is continuous function for all x belongs to integers except z. ये तो पक्का है कि इनके लिए continuous है. देखो cos continuous होता है, So your function is continuous between -2 including to -1 not including. Your function is continuous for -1 including to x not including. मतलब ये सारे फंक्शन तो कंटिन्यूस है. कांस्टेंट फंक्शन भी क्या होता है, कंटिन्यूस ही होता है. ये भी कंटिन्यूस है, ये भी कंटिन्यूस है, ये भी कंटिन्यूस है, ये भी कंटिन्यूस. कोई दिक्कत नहीं है. दिक्कत कहाँ आ रही है, या फिर प्रोबेबली सोचना कहाँ पड़ सकता है, वेर योर फंक्शन चेंजेस द डेफिनेशन, राइट? हर्षित, इज दैट क्लियर?
हाँ सर समझ रहा हूँ.
ओके, देखो बाकी सब जगह देखो कोसाइन एक्स तो कैसा फंक्शन है, कंटिन्यूस है. सो योर फंक्शन इज कंटिन्यूस बिटवीन -2 to -1 union. Your function is continuous from -1 to 0. Your function is continuous from 0 to 1. अब प्रॉब्लम कहाँ हो सकती है पॉसिबली, at these junctures. यहाँ पर देखो डेफिनेशन चेंज हो रही है. At these integers your definition is changing. So there may be a problem where your function's definition is changing, right? So we need to be cautious here, and we need to see that whenever your definition changes, probably there you may find that your function is different. ये तो समझ में आया ना. देखो ये इंडिविजुअली फंक्शन देखो, कोसाइन एक्स तो कंटिन्यूस होता है, राइट? कैसा भी लिखा हो, कोसाइन 2x समथिंग लिखा हो तो भी कोई फर्क नहीं पड़ने वाला. कोसाइन एक्स इज अ कंटिन्यूस फंक्शन. अगेन सी कोसाइन एक्स, इट इज अ कंटिन्यूस फंक्शन, कोई दिक्कत नहीं. बट व्हाट अबाउट at the juncture where you are changing the definition? So I'll write here, at integers one need to find. So at integers one need to find. Isn't it? So let us check from here. इधर है, पहले काम करते हैं, पहले जीरो पे चेक करते हैं, राइट? सो ये डेफिनेशन में ही उतार देता हूँ, नहीं तो तू बार बार कंफ्यूज करोगे. एक कुछ है. एक ठीक है. ये था तुम्हारा फंक्शन मोटी मोटा. बाकी भी होगा, आई एम नॉट सेइंग कि इसके अलावा नहीं होगा, इसके अलावा भी चलता ही रहेगा फंक्शन, बिकॉज इंटीजर्स तो इनफिनिट होता है ना. सो इंटीजर्स तो इनफिनिट होता है, दिस इज गोइंग टू कंटिन्यू. एक बार एक आइडिया लेते हैं. लेट अस चेक द कंटिन्यूटी एट x इक्वल टू 0. कैसे चेक करें? लिमिट h टेंड्स टू 0 f ऑफ माइनस h, लेफ्ट हैंड लिमिट. सो देखो 0 माइनस h पे कौन सी डेफिनेशन पे चले जाओगे, ये डेफिनेशन दिख रही है. सो आई विल सिंपली राइट लिमिट h टेंड्स टू 0 माइनस ऑफ cos ऑफ माइनस 2h minus 1 divided by 2 pi. h tends to 0 पे 0 हो जाएगा. So this will be simply limit h tends to 0 पे 0 हो जाएगा. This will be cos of pi by 2, right? What is cos of pi by 2? 0. What it is equal to? It is equal to f of 0, and it is also equal to f of 0 plus h, because for all x greater than 0, less than 1, your function is 0 itself. So you can see that your function is continuous at x equal to 0, right? Also understand that your function is continuous for all r except z. Like this is for with certainty, I'm saying. Why with certainty? Because the function cosine x is continuous function. So on any for all these subintervals, you can find that these on subintervals your function is some cos function, and so cos function being a continuous function, so this particular function would be continuous for all r except at z, which will need a further evaluation. So at x equal to 0, you can see that your function is continuous, isn't it? Similarly, at x equal to 1 also you can see that your function is continuous. क्यों? देखो at x equal to 1 क्या होगा? f1 करें, f1 simply 0 होगा कि नहीं होगा? ये देखो f1 0 कैसे हो जाएगा? यहाँ 1 रखो तो 2 minus 1 is 1, 1 by 2 cos pi by 2, 0 हो गया कि नहीं हो गया? f of 1 plus h भी करोगे तो क्या आएगा? 0 ही आएगा. देखो चेक करके देखो. It will be equals to what? It will be equals to cos of 2 plus h minus 2 divided by 2, और यहाँ पे क्या आएगा? 2 यहाँ पे क्या था? 1 plus h था ना, सॉरी 2h. तो यहाँ पे क्या था देखो, यहाँ पे रखो 1 प्लस एच, यहाँ पे रखा 1 प्लस एच, तो कितना आएगा 2 माइनस 1, सॉरी 2 माइनस 1, तो ये सिंपली हो जाएगा 1 प्लस 2h डिवाइडेड बाय 2 और इसका कोसाइन, और यहाँ पे एक पाई भी आएगा, यहाँ पर एक पाई आएगा। एच टेंस टू 0 पे सिंपली 0 जाएगा, तो cos पाई बाय 2 कितना होता है 0 ही तो होता है। Are you getting my point? So your limit h
हाँ
tends to 0, f of 1 plus h is also 0. Similarly, you can verify that f of 1 minus h would also be 0. That is clearly seen because for all x less than 1, your function is 0. ठीक है, ये वायलेट कलर है, ये ब्लैक कलर ध्यान से देखना है, ये इक्वलिटी नहीं है, ठीक है। सो एक आइडिया लग रहा है, वन आइडिया यू कैन टेक, वन आइडिया, एक आइडिया लग रहा है कि हाँ ठीक है, at integers x equal to z also f is continuous. Let us see. So I'll take a general case. Let's say n belongs to z. कोई n belongs to z लिया है, ठीक है। I've taken an integer which is n belongs to z, right? ठीक है, I've taken an integer which is n belongs to z, right? Now if I take what will be value of fn, so value of fn simply would be greatest integer of n is n only, cos of 2n minus 1 divided by 2 into pi, right? Or in other words, n into cos of n minus, I should write what? इसको ऐसे रन दो ना. So it is simply 2n minus 1 pi divided. Now place n equals to 1. So at n equals to 1, what it would be equals to 2 minus 1 pi. 2 minus 1 is 1, pi by 2 is 0. At n equals to 2, 2 into 2 is 4, 4 minus 1 is 3, 3 pi by 2. Cos 3 pi by 2 is 0. N equals to 4. So for all n belongs to integer, you can say that this particular term fn would be 0. Yes or no? हर्षित, yes or no? नहीं आ रहा तो प्लीज पूछ लो.
नहीं सर, एक सेकंड बस।
देखो, हम क्या, हमें ये आइडिया लग गया कि हाँ ठीक है, इंटीजर्स पे हमारा फंक्शन क्या आ रहा है, कंटिन्यूअस ही आ रहा है, क्योंकि लेफ्ट हैंड
हाँ
जाओ
सर।
चाहे राइट हैंड जाओ, चाहे फंक्शन की वैल्यू निकालो, 0 ही आ रहा है। अदरवाइज
हाँ
देखो,
सर।
फंक्शन वैसे ही कंटिन्यूअस था, तो एट इंटीजर्स एक आइडिया लग रहा है कि हाँ फंक्शन कंटिन्यूअस हो सकता है। तो मैंने क्या किया, जनरल केस लेने के लिए मैंने मान लिया आई एम टेकिंग एनी एन बिलोंग्स टू जेड, कोई भी एक इंटीजर ले लिया एन, और मैंने क्या किया, एफ एन निकालने की कोशिश की। अब मैं कह रहा हूँ कि एफ एन माइनस एच निकालने की कोशिश करो। What would be fn minus h? Remember, greatest integer of n minus h, n में से थोड़ा सा भी हल्का कम कर दिया, और यहाँ पे क्या है, cos of 2n minus 2h minus 1 divided by 2 times pi. Is that clear? h tends to 0, this will go to 0, forget about it. And as h tends to 0, चाहे कितना ही छोटा क्यों ना हो, n में से कुछ चीज तो घट रही हो जाएगा, n minus 1 into cos of 2n minus 1 pi upon 2, right? This again would be what? 0 only. Cos of 2n minus 1 pi by 2 is 0. So n minus 1 into 0 भी क्या होता है? 0. Similarly, if you want to find right hand limit, it will be simply n into cos of 2n minus 1 pi. Again what? 0. So whether you take left hand limit at x equal to n, at x equal to n, whether you take left hand limit, whether you take right hand limit, or whether you find the value of function at integer, it will be equal to 0 only. That implies what? F is continuous at z also. It implies what? F is continuous everywhere. Is that clear or not? देखो, पहले हम किस assertion पे आए थे?
हाँ सर।
Probably f is continuous for all real number except z, which because with certainty we don't know. So with certainty करने के लिए हमने क्या किया? We started checking at these points where your definition is changing, and the definition is changing at integral points, right? So let us check that at all these integral points. So at integers, I'm finding that my function is continuous. So a function was already continuous for all r except integers. At integers, it is continuous. So overall function is continuous everywhere. So question क्या पूछा गया था? Check करें. Function is discontinuous at no integral point. C. Is that clear?
या सर।
ठीक है, इस तरह के क्वेश्चंस एग्जाम में ज्यादातर यू विल फाइंड they are going to ask एक दो क्वेश्चंस और करते हैं, then probably from tomorrow I'll take only one session, and then from day after we'll have two sessions like continuous. Today I came late from the lab now, so overall today we'll have one session, tomorrow again I'll take a one session in lieu of today's session, and then from July 2 onwards we'll have a continuous. So
Okay, sir.
okay, so differentiability will start tomorrow, but just I'm giving you a homework. Try to do this. This is from, I think, JEE exam only. The question is, let f of x equals to what? Be equals to 1 plus modulus of sin x raised to power a upon mod of sin x, where x varies from minus pi by 6 to 0. At x equal to 0, it is simply equals to b, and at x greater than 0, less than pi by 6, this is equal to e की power of tan x 10 to x divided by 10. Find the values of such that f is continuous at x equal to 0. Find the value of a and b such that f is continuous at 0. F is continuous at 0. You have to find this. This is a simple question again. Simply तुम्हें limit evaluate करनी है. So you have to take a left hand limit and you have to take a right hand limit. So just as a hint I'm giving, try to find the right hand limit and try to find the left hand. So right hand limit क्या हो जाएगी? Limit s tends to 0, f of h. So to the right of it, it is e की power tan 2h divided by 2h, and then divided by tan of 3h divided by 3h. So what you will get? You will simply get, I think this will be equals to what? It will be equals to, so you have divided by 3h, so you have multiplied with 3h, you have divided by 2h, so you multiply by 2h. Is it clear? Now as h tends to 0, this would be what? 1. As h tends to 0, this would be 1. Remember, limit x tends to 0, tan x upon x is always equals to what? 1. Is that clear?
Yes.
So this
Yes,
will be
yes.
e की power of 2 by 3. So right hand limit should be equal to the value of function at that point. So your b should be equals to what? E की power 2 by 3. Is that clear?
Yes.
And if you want to take the left hand limit, then left hand limit will be what? Left hand limit would be again value of the function at that point, and this particular left hand limit would be what? So as x tends to 0, this is going towards 0, this is going towards infinity, isn't it? So this limit to the left hand, I'll write limit s tends to 0 f of minus h would simply be equals to what? E की power a तो होगा, थोड़ा ध्यान से देखो. एस एच देखो यहाँ पर क्या रहा है? 1 प्लस साइन एक्स का मॉड, और इसको एक बार ले लो 1 अपॉन साइन एक्स का मॉड और इस होल की पावर ए. अब सोचो x टेंड्स टू 0 पे दिस इज टेंडिंग टुवर्ड्स 0, दिस इज टेंडिंग टुवर्ड्स इंफिनिटी. रिमेंबर द फॉर्मूला 1 प्लस लैम्डा x रेज्ड टू पावर 1 अपॉन x as x tends to 0 is simply equals to what? It is equal to e की पावर लैम्डा. तो ये हो जाएगा e की पावर a, isn't it?
हाँ, sir.
So e की power a should be equal to the value of the function at that point. And what is the value of the function? E की power 2 by 3, if you remember. So your a must be equal to 2 by 3. So your a must be equal to 2 by 3, and your b must be equal to what? E की power 2 by 3. Is that clear? So such easy questions
Yes,
are going to be asked in your examination. So tomorrow we will start with probably differentiability, or we'll see a few questions for continuity also. Don't worry. So I'll meet you tomorrow. So we'll be getting later. Okay.